Hi everyone, we are team number 10, Lee Junsu, Go Jae-sung, Shin Sun-woong, Im Hyung-kyu, Yang Jae-young. Our target building is London Aquatic Center, which is designed by Zaha Hadid. This is content of our presentation. First, we'll talk about general information about our target building, London Aquatic Center. Second, we'll talk about the main design issues. Third, as you already know that this is the most important part, we'll talk about construction engineering issues of this building. And finally, we'll talk about other notable issues. This building is designed by famous architect Zaha Hadid. Her full name is Zaha Mohammad Hadid. She was born on October 31, 1950 in Baghdad, Iraq. She is specifically famous for her dissociative architect regardless her own will. She has designed many buildings such as Rosenthal Center of Contemporary Art, BMW Central Building, Hagberban, DDP, and so on. And now, let's focus on our building. Our building is built for London Olympic. Its type is swimming pool, which is used by athletes on the Olympics. Client is Olympic Delivery Authority. As you can see in this picture, this building is located at the southeastern edge of Queen Elizabeth Olympic Park on the new Stamford City Bridge. Due to this location, it gives pedestrian access to the park from the new Stamford City development and public transportation. This building is designed to reduce the record of athletes as much as they can by allowing the water circulation to stop immediately during the game, and flattening the pool walls and the water level, allowing overflowing water to fall directly into the drainage group next to the pool. This can effectively reduce water resistance and hence can reduce the record. Next, we introduce about main design issues of London Aquatic Centers. The main concept of Aquatic Center is the fluid geometry of water in motion, and most characteristics is the bridge next to the stadium was connected to the second floor. It naturally fused as if building has existed there from the start. The building's greatest inspiration is the flow of waves. The purpose of this place was to be a swimming pool, and Zaha Hadid's ability to freely handle curves was well matched. The architectural concept of the London Aquatic Center is inspired by the fluid geometries of water in motion. It creates space and a surrounding environment that reflect the riverside landscapes of the Olympic Park. And the undulating roof sweeps up from the ground as a wave, enclosing the pools of the center with a unifying gesture of fluidity, while also describing the volume of the swimming and diving pools. Next is architectural plan. There are two forms of aquatic center. One is Olympic mode and the other is legacy mode. In the case of Olympic mode, the shape of the building becomes wider than Olympic mode. The building was temporarily built on both sides. It created 7,500 seats to accommodate the audience. After the Olympic Games, it made a swimming center available to citizens. At this time, the audience seats made of rubble were removed. The result is the current aquatic center. There are now approximately 2,800 seats indoors. The drawings show the following. In the case of Olympic mode, has wings on both sides. The seats were built in boards, not fixed in foam, so that they could be removed after the Olympics. But legacy mode, it is shaped like a curved building. It first started construction in June 2009. In 2011, construction of the building was completed in Olympic mode. In 2012, after the Olympics, the two sides named wing was constructed in building. By 2013, the building was completely transformed into legacy mode. This is the architectural plan of the building in Olympic mode. In turn, there are pictures of drawings on the ground floor, the first floor, and the second floor. This podium element contains a variety of differentiated and cellular programs within a single architectural volume, which is seen to be completely assimilated with the bridge. The podium emerges from the bridge to cascade around the pool hall to the lower level of canal. This is the architectural plan of the building in a legacy mode. And elevation. The Olympic season in short is like this. This building and structural arrangement ensured 7,500 temporary spectator seats. It was installed along either side with no structural obstructions. In total, 15,000 temporary seats provided, and now glazing panels are located in the temporary seating position, leaving a capacity of 2,500 seats for community and events. Now, construction engineering issues. There are two wings besides the main building. They are capable for 47,500 spectators, and after the Olympic Games, they were removed. The size of the building is 160 meter by 80 meter size and 45 meter height. They used cast-in-place concrete pile method in foundation work. As you can see at the right picture, this method takes several steps. First, make a hole with the desired height and put a steel frame in it. After that, filling it thoroughly with concrete. The building used about 1,000 concrete piles in foundation works. The foundation construction began after the remediation process was completed. The method of using cast-in-place piles as a foundation type was chosen because the method helped to stabilize the soil after the remediation process. The roof of the building is mainly made of steel truss structure. It spans from north to south, and they cover main area without any in-between supports. The 11,000 square meter structure spans a column-free area 160 meter long and up to 90 meter wide. The steel structure of the roof rests on three anchor points, two smaller pillars at the northern and the building and one large pillar at the southern end. This column-free structure was possible with complex truss structures. In the roof structure, the center fan truss carry load in truss action, spanning between north and south transverse trusses, which carry the load down to the supporting bearings on the concrete structure below. Also, they used fixed spherical bearings on the northern end to act as pins. The southern wall with outer two bearings can slide in both central axes of the building, and the central bearing only allowed to slide along the central axis of the building. These moving bearings allows to simplify the substructure construction and to endure under wind load and thermic expansion. The surface of the roof is mainly made of flexible aluminum sheets. They applied Collective XT cladding system to make a smooth and stable aluminum cladding. This cladding system overlaps each sheet, sealing the space beside the sheets. Finally, other notable issues. The level 1 pool was placed for ease of access as well as to suit the regularity required for competitive pools. The volume is enclosed except for two large openings in the pool area, exposing the structure within. These windows allow the public to view into the pool area, thus establishing a closer relationship with the community. A great advantage of this scheme was the amount of exterior space made possible even with a fairly large building occupying the lot. A park-like atmosphere was generated through a gradual sloping site with grassy open spaces, footpaths, a volleyball court and sandbox, and a water fountain wading pool. With the recreational pool lifted up, it is possible to walk through the site from one end to another in the north-south direction, allowing pedestrians to be fully engaged with the entire site. This is the end of our presentation about the Rangon Aquatic Center. Thank you for listening.